Yes, this is Unit 12, Lesson 2, Surface Areas and Volume of Pyramids. Okay, so here's what we've got going on with this. There's more than one type of surface area, so this is why this is called surface areas, because you have three different types of surface areas, but we have a single type of volume. Okay, so we're going to talk about these, but before we get started any farther, what you need to do is you need to get some paper and something to write with, just in case you have any kind of questions about this. And it's very simple to do. All you have to do is put the video on pause, write down your question, then start the video up again, and you're ready to go. Okay, so let's take a look at what we got. So definitions and such. We got the area types that you're going to find in a pyramid. Okay, the area of the base is the first one, and depending on what your base is, depends on what kind of process you need to go through to find the area. Because if it could be a square, which is the simplest case most of the time, uh, could be a hexagon, in which case you'd have to use the apothem, or it could be a pentagon or whatever. Okay, could be a triangle, but it will always be a polygon of some sort. But you need to be prepared to find the area in whichever way it goes. Okay, the next type is called the lateral surface area. This will always involve finding the area of triangles. Okay, the lateral area of the pyramid is simply the sum of all the triangular lateral faces put together. So if it's a hexagon, you're going to have 6 triangles. If it's a triangle, you're going to have 3 triangles. If it's a quadrilateral, you'll have 4 triangles. Okay, the next type is called the total area, which is simply a sum of the first two, the area of the base and the lateral areas put together. That will give you the total surface area of the pyramid. Okay, so let's take a look at example 1 and 2. Okay, so they want us to find the lateral area of a square pyramid. So here's the one they gave us. If you notice that one of the base edges is 15 feet, so we're going to use that to find the area of the base in just a minute. Okay, the height of the pyramid is 12 feet. That is not going to be used directly. What we're going to use that for is an indirect way to use this little right triangle in here so that we can find this slant height, which is this hypotenuse of this right triangle. So we're going to redraw that little dotted right triangle out to the side here so we can see what we're looking at. So that we know that one leg is 12 and the other leg is half of the length of the side of the square, so that's 7.5 feet. Okay, so now that we have a right triangle and we know the two legs are A and B, if you're a Pythagorean theorem fan, simply comes down to using the Pythagorean theorem in order to find the slant height, which is what we're going to need to find the area of the lateral faces. Okay, so the slant height squared, or the hypotenuse squared, is equal to the sum of the two legs squared. Okay, so the slant height squared in this case is equal to 12 squared plus 7.5 squared. So the slant height squared is equal to 144 plus 56.25. So the slant height, which is the square root of both of these sides, becomes the square root of 200.25, which is approximately 14.15 feet. Okay, so now we're ready to find the area of one of the triangles. So the area of a triangle is equal to 1/2 of the base times the height, so 1/2 of 15, which is the base of this triangle because that's what the height is measured from, times the height of the triangle, which is 14.15. So the area of the triangle will come out to approximately 106.13 square feet. To get the lateral surface area, since there's 4 triangles, we will simply multiply that 106.13 times 4. So that gives us what we got here at this next level. So that gives us approximately 424.52 square feet. Okay, example 2 wants us to find the total area of the square pyramid. So this means we need to add the area of the base to the lateral area that we just found. Okay, so the area of the base, as we noted earlier, since it's a square, is simply the length of the side of the square, which is 15 squared, which is equal to 225 square feet. Okay, so now we're ready to find the total area, which is simply the base area added to the lateral area. So this gives us the total area is equal to 225 from the base plus 424.52 from the lateral surfaces is equal to 649.52 square feet. Okay, so let's go ahead and look at a little bit more. This is telling us about the volume of a pyramid. The volume of a pyramid is equal to 1/3 of the area of the base times the height of the pyramid, not the slant height. This is the height. That is the 12 that we talked about in the previous example. Okay, so the formula is usually abbreviated as 1/3 of the area of the base times the height. That 1/3 is interesting though, because what that means is if you'd had a cube of exactly the same shape as what we had as the pyramid previous, then what would happen is that the volume of the pyramid would be exactly 1/3 the area of the cube, and that's what that 1/3 is actually referring to. Okay, so let's look at example 3. So what's the volume of a square pyramid whose perimeter is 128 meters and whose height is 42 meters? Okay, since they gave us perimeter and it is a square, this means that we have to know how to find the length of one side of the square, which is simply take the 128 meters and divide by 4. Okay, so the side length is equal to 128 divided by 4, which is 32 meters. Okay, the volume is very simple to find because all we do is get the area of the square, which is going to be 32 squared, is noted in what we've got written here. So the volume is equal to 1/3 of 32 squared times 42, which is the height of the pyramid, gives us a total of 14,336 cubic meters of space that's inside this particular pyramid. Okay, the last example, which is 4, is what is the volume of the square pyramid that they're giving us in this case. Okay, so this time they gave us one. It's a square pyramid again, so they told us the side length is 18 centimeters of the square. Notice they gave us the slant height, so this means we're going to have to use the Pythagorean theorem to find the altitude or the height of this so that we can actually figure out what our volume is. So once again, we're going to redraw the little right triangle out to the side here so that we can see it clearly. So if you notice, one of the legs is labeled H for height. Excuse me. The other leg is 9, which is half of the 18. And we know the hypotenuse in this case, or the slant height, is 20. Okay, so this means that we're going to set up our Pythagorean theorem this way. So the height squared plus 9 squared is equal to 20 squared. So the height squared plus 81 is equal to 400. So h is equal to the square root of 400 minus 81, which is 319, and that gives us approximately 17.86. Okay, so the volume here is 1/3 of the area of the base times the height. So the area of the base is going to be 18 squared. So it's going to be 1/3 of 18 squared times 17.86 that we found in the previous step. That gives us a net of 1,928.88 cubic centimeters. Okay, that completes this lesson. Remember, if you had any questions, make sure you bring them with you to class tomorrow, and we'll be glad to discuss those with you before we start any work. Thank you very much. See you later.